Hello everyone, welcome back to this online class. Today we are going to look at numerical solution of ordinary differential equations, and in particular we are going to look at Milne's predictor-corrector method. So we have this question. We are given the tabular values below for the ODE. dy over dx is equals to 1 over 2 1 plus x squared times y squared, with the state size h is equals to 0.1. So we have the table of x versus y, as you can see. So we are asked to use Milne's predictor-corrector method to compute the value of y of 0.4 correct to 6 decimal places. Now, what is important about this Milne's predictor-corrector method? Of course, it is of fourth order. This is fourth order. Is that you must know the first four values of y. So you must know the value of y0, which is this one, y1, y2, then y3. Those must be given. If they're not given, then you will be asked to first of all find them using maybe Runge-Kutta method or Euler's method or modified Euler's method or Taylor series method, so that you obtain the first four functional values. So here we have x0, x1, x2, x3, x4. So what we don't know is the value of y4. So the task is to find y4. Find y4, which is the same as y of x4, and this is the same as y of 0.4, using Milne's predictor-corrector method. So this is how to go about this question. First of all, if you look at our ODE, you realize that our x0 is equals to 0, y0 is equals to 1. As you can see from the table, x1, x2, we can read them from the table. Our f of x, y, is equals to 1 over 2 into 1 plus x squared times y squared. So we start with the predictor formula, get the value of y4, and then use the corrector formula to correct the predicted value, or simply to obtain the most accurate value of y4. So you write Milne's predictor formula, Milne's predictor formula. This is the formula that yn plus 4 star is equals to yn plus 4 over 3h, 4 over 3h into 2 times f subscript n plus 1 minus f n plus 2 plus 2 fn plus 3. That is the predictor formula. And let me give you the corrector formula, because we'll also need it. Milne's corrector formula. Formula is that yn plus 4 is equals to, that should give us yn plus 2 plus h over 3 into fn plus 2 plus 4fn plus 3, fn plus 3 plus fn plus 4. Remember, we are iterating. We write for n is equals to 0, 1, 2, 3, etc. So let me bracket these formulas. They're very important. You only need to master these formulas because how to apply them is very easy. Just mastering how the formulas look like is what might be cumbersome. But once you know the formula, it's very easy to apply the formula when you're given an initial value problem. So let's see how to apply it. We start with n is equals to 0. We are iterating. So you write, put n is equals to 0. What are we going to get? Let's start with the corrector formula. So not corrector, but predictor formula that y4 star is equals to y naught plus 4h over 3 into 2 f1 minus f2 plus 2f3. So how do we calculate those functional values, f1, f2, f3? Remember, when I write fn, is the same as f of xn, yn. When I write fn plus 1, that is the same as f of xn plus 1, comma, yn plus 1, etc. So let's see how to find f1. So you write here f1 is equals to f of x1, y1. And from our definition of f of xy, it is 1 over 2 times 1 plus x squared times y squared. So where there is x, I'm going to put x1, and where there is y, I'm going to put y1. So it will be 1 over 2 into 1 plus x1 squared times y1 squared. And so when I substitute the values, I'll have 1 over 2, 1 plus our x1. We go back to our table. x1 is equals to 0.1 and y1 is equals to 1.06. So here we'll have 0.1 squared into 1.06 squared. Press this in your calculator. You need to get 0.567418. 1567418. Let's get f2. That is equals to f of x2, y2. And so this will be 1 over 2 into 1 plus x2 squared, y2 squared. That is 1 over 2, 1 plus, our x2 is 0.2. We need to square this. What about our y2? Check from the table. That is 1.12. Again, that is supposed to be squared. 1.12 squared. Press this in your calculator. That should give you 0.652288. 652288. We also need the f3. as f of x3, y3, and that's equals to 1 over 2 into 1 plus x3 squared times y3 squared. That is 1 over 2, 1 plus 0.3 squared. What about our y3? We can refer to the table. Our y3 was 1.21. We need to square that. So we have 1.21 squared. When you press in your calculator, you need to get F3 is equals to 0.797935. 797935. So with those, we can now be able to find y4 star because I already have this. So you can say that therefore, y4 star is simply equal to y0. Our y0 was 1. Y0 was 1 plus 4 over 3 times h, which is 0.1, times twice of f1, 0.567418, minus f2, 0.652288, plus twice of f3, 0.797935. So this should be equal to, when you press in a calculator, you need to get 1.277122. 1.277122. So that is the predicted value. Now, before you obtain the corrected value, let's first of all compute F4. Before that, let's write this corrected value. Remember, this one is the predicted value. You can comment on this and write predicted value of y4. You predict and then you correct. Remember, that's the pattern. Predict and then correct. So the corrected value, when n is 0, we substitute into this formula so that we get y4. So that will give us y4 is equals to y2 plus h over 3 into f2. The next is plus 4 f3 plus f4. Plus 4 f3 plus f4. Already we have the value of f2 and f3. We have them from here. F2 is this, f3 is this. Let's compute f4 and then we substitute into the corrected formula or the corrector formula. So now f4 is equals to f of x4 y4. But you see, we don't know the value of y4, so we use y4 star. Because we don't know the value of y4, we are going to use the predicted value. So this is the same as 1 over 2 into 1 plus x4 squared y4 star, and this should be squared, is equals to 1 over 2, 1 plus, our x4 was 0.4, and our y4 star we have just found 1.27 at 7122. When you square this, you press in your calculator, you need to get f4 is equals to 0.946004. 946,004. So with this now we can get the value of y4 because now we know the value of f4. So you can just say that therefore y4 should be equal to y2. Y2 you can read from the table. Let's go back to our table. And y2 is 1.12. So that's what I write. 1.12 plus h over 3, 0.1 over 3 into f2. Read the value we got as f2. That was 0.652288 plus 4 times f3, which is 0.797935, then plus f4, which we have just found as 0.946,004. And when you press this in your calculator, you need to get 1.279668. 279,668. So this is the corrected value of y4. And the corrected value will always give you the value that you wanted. So you can write corrected value of y4. So that value we have found, it is the value of y when x is 0.4. So this is y of 0.4, which was missing from the table. Remember, if you want the value of y when x is 0.5, you proceed with the iteration now when n is 1, because that will give you y5. But you have not been asked to find that from the given question. So our answer is 1.279668, correct to 6 decimal places. So thank you all for watching this video. Please subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we look at more problems involving numerical solution of ODEs. Bye-bye.